This might feel a little bit, it'll be a slightly funny explanation. Okay, y'all. Man, I got like these weird pieces of paper everywhere. So I'm going to take this piece of paper, I'm going to shoot it from here. You gonna bear with me? Think it's going to go in? When I shoot it, and that's a trial, yes? What kind of trial is it? Is it binomial? I would call it binary. Two possible outcomes. But I'm not sure.
There's not a large number of trials.
Well, binary just means we have two possible outcomes. Are we comfortable with that?
Yeah.
And there exists some probability that it's going to go in. We don't know what that probability is, but there is like a probability, right? It didn't go in. So close. And if I come back to the same spot, the probability of it going in seems about the same, right?
Closer.
These are the closest I've been in this is the third time we're doing this. Okay? So, how many shots do you think it's going to take me before I make it? Oh, that was a bad one. That one was real bad. Yesterday it took me 6 shots in one of the classes and 1 in the other one. That was bad.
Nice!
For those of you at home, because the recording's already going even though it's not up there, it just bounced off the counter and in, which is why we were like, oh, that's not going in, and you know. All right, so in this particular case, you guys, so I took this piece of paper and I shot it, right? Did I have a set number of trials in this instance? No. And when we talk about my variable, let's repeat what I just said, though. Well, second period yesterday, it took me 6 shots. And then 8th period, it took me 1. And for you guys, I stopped counting. Was it like 4?
It was 4.
Was it 4? Okay. So what was the variable? Like when we think about it, what changed between the different classes? The number of trials. Is everybody with me? So now, what if I had taken 10 shots and we just counted how many I made? That would be a set number of trials, right? Yeah. Okay. So, and then, so for it to be binomial, we have set number of trials okay? And X is equal to a number of successes, okay? Is everybody with me? This new one we're going to talk about today is very, very similar, except for it's called a geometric variable. And the distinction between a binomial versus a geometric is for geometric, X is equal to the number of trials until success. So one of the easiest things for you guys to do will be to say, what does X stand for? And you noticed when we were doing that review, I started really emphasizing what does X stand for, okay? Because that helps me make the distinction between, is it binomial or geometric? We good so far? All right, so geometric distributions are binary in the sense that for each trial, you have 2 possible outcomes. Now, I want you guys to think through. When I missed the first shot, did that influence whether or not I was going to make the second shot? Okay, so one trial doesn't affect the other. All right. We're going to find the number of trials until success. So X is somehow going to use the word until. Like, really, that's the big idea. And there's another word that could help, like, really. The word until is huge. If I say the word first, that would also, like, how many shots until my first make? Those are things that might suggest.
Wait, does it, for the indefinite, does it or does it not?
I said doesn't. It doesn't affect. Okay. And lastly, we have a same probability of success each time, over and over and over again. So on specs so far, do you guys feel pretty decent about the distinction between binomial and geometric? Okay. In other words, if you don't have an n, it's not binomial. Does that make sense? Okay. Now, you guys, let's go ahead and say that my probability of making it was 1 in 5. So 20% instead of 15%. Cool? If my probability was 1 in 5, on average, how often, what would you expect it to, how many shots do you think it would take me on average if my probability was 1 in 5? Just using your intuition. 5. You guys, does that kind of make some sense? Does it feel about right to you? Why 5?
Just once you get to 5, you should.
It should balance around like 1 every 5 times, right? Okay? All right. So, your intuition is 100% correct. The expected amount of trials for a geometric distribution is 1 over whatever the probability is. So when I said 1 in 5, and you said 5, 1 over 1/5 is 5, is like flipping it. 1 over a number is its reciprocal. Okay? All right, so now, how many of you guys have ever played Monopoly? It's a pretty decent game, right? It does take forever. My strategy is always to buy up all the railroads, because I feel like if you have all the railroads, like every street around the board has lots of railroads on it, right? Or they'll have to pass, they run the risk of going through the railroad. That would be a fun probability question. There's 10 spaces. What's the probability as someone goes down? That's a fun probability question. I gotta think about that more. Okay, anyway, y'all. In Monopoly, if you land on the go to jail, you go directly to jail. Do not passcode. Do not collect your $200 paycheck. You guys with me? And then you have two options at that point. You can pay money to get out of jail, or you can roll, and if you get doubles, you get out of jail. And you can do that for up to 3 turns. Is everybody with me? So we're going to now, if you roll doubles on the first turn, are you going to keep rolling doubles again? No. So you guys see that this is geometric. You're gonna keep using your turns until you get doubles. And after 3 turns, you're done. Yeah? Is everybody good that we see that this is geometric? All right. So let's go ahead and let T equal the number of turns you have. So T is geometric. Now, when you roll the dice, do you have 2 possible outcomes in this setting? What are they? Doubles? Not doubles. So, yep, that's there. Do we have the same probability of success each time?
Yeah.
Every time you roll, do you have the same probability of getting doubles?
Oh, yes.
Yes. Okay. All right. And do we have a set number of trials? None. No. Depends on if we get doubles the first time or not. Okay. What is the probability of rolling doubles? Here. Do you guys remember, it's not there anymore, that table I had of the ways you can roll 2 dice? How many ways can you roll 2 dice? Well, you take all the possibilities for the first dice is 6 times all the possibilities for the second dice is 6 times 6 is 36. You have 36 different ways you can roll 2 dice. We're comfortable. Okay. Of those 36, how many are doubles? 6. 1 and 1, 2 and 2. 6 out of 36. All right, you guys, can I give you a simpler way of thinking about it that I had to get to the answer first before I thought of it this way? Let's say I take those 2 dice. One of them's going to land first, right? Does it matter what that one lands on for it to be doubles? No. So we're really just saying what's the probability that the second dice matches whatever came up on the first dice. So if I roll my first dice, I get my number. What's the probability the second one has the same number as 1 out of 6? All right. So how many rolls would you expect it to take to get doubles? When we hear that word expect, I need you guys to think of what measurement? When I talk measurement, I'm talking about statistical measurements. We have several we've been working with, mean, standard deviation, etc. Which one is my expected value?
Mean.
The mean. So if I ask you to find the mean of t, there's a formula for the mean of t. It is that 1 over p we were just talking about. So we would do 1 over 1/6, which is 6. On average, it would take 6 rolls to get doubles. What do you guys think so far? Reasonable? All right. Now, what does t equals 3 really mean? It means it would take exactly 3 turns to get doubles. Now, yeah. If it takes exactly 3 turns to get doubles, did you get doubles on the first turn? Yeah? No. If it takes 3 turns to get doubles, the first turn is going to not get doubles, so I'm going to have a 5/6, because if it's 1/6 that you get doubles, it's 5/6 that you don't. Okay, so for the first turn we have a 5/6, right? Times for the second turn we have a... Did we get doubles on the second turn? No. Times for the third turn it would be 1/6. So hear me out, y'all. You know how we were just talking about that formula for binomials? There is a formula for geometrics, and it's going to consist of 2 pieces. The 1 minus piece, all your failures, times your 1 success. Are you with me? And so when it was x equals 3, I had 2 failures because the third one was the successful one. What if this had been t equals 9? How many of 5/6 would I have? 8. And then the 1 success. Do you guys see what I'm saying here? Okay? So in reality, this is to the x minus 1 power, and then this is that 1 to add up to all the total trials. Okay? All right. I think that works out to be 0.11, but I would sure love somebody's help with that.
Yeah, 0.115.
Okay. Now, in Monopoly, you get up to 3 turns to do it, right? So that means you could get it on the first, the second, or the third. So what is the probability that t is less than or equal to 3? Well, I could do t equals 1 plus t equals 2 plus t equals 3. Or I wonder, we've done less than or equal to stuff before, right? And how did we do that? Like, it was when it was binomial, we went to our calculators and we did binom CDF. I wonder if our calculator's pre-programmed with a geometric CDF. But if we're going to use that instead of like doing all that work, we're going to write down that the word is that we use the geometric distribution with p equals 1/6. They're down there. I think there's a geometric PDF and CDF. I'm pretty sure they're the last two in the menu. The very last two. Do you know that you can get to them by hitting the up button right away? Too. If you don't want to scroll all the way down, you can just hit up and it'll take you to the bottom. This one would be CDF because it is less than or equal to. So all those rules with the binomial PDF and CDF, they apply here too.
And the probability is 1/6.
And the probability is 1/6.
Are you allowed to put a fraction?
Yep. And you should get 0.42. By the way, that's a low enough probability that I just pay the money. I'm not going to wait and lose my turns because my turns in Monopoly are the ways you make money, right?
Do you put 3 for the x value?
Put 3 for the x value, yep. Because it's not a number of trials anymore. It's the number of trials is the variable.
It gave me an error last time. That's why I was making sure.
Well, why'd you mess up? Everybody good? 3. If you're doing less than or equal to 3, whatever. In the same way that x value before was what was in that whatever you're finding that probability of.
I got 0.8.
Well, you did something wrong. No, the probability was 1/6, yeah.
Oh.
And the answer is 0.42.
Oh.
All right, let's talk about this next example because it's a really good example of the way the College Board might ask you some nuanced questions and quite appropriate considering the past few weeks in Grandview while also the World Cup going on. So let's go ahead and say we have a professional soccer player who is able to score on 84% of his penalty kicks. Is everybody with me? All right. And we're going to assume that every time he makes an attempt at scoring, taking a PK, that each kick is independent. Okay. So, he's going to go be in a series of games. What is the probability that the first time he fails to score is on his 5th penalty kick? Now, guys, as I look at this makes me want to write the probability x is equal to 5. Let's start with, does that make sense? And this is how I start to think this through, okay? All right, and if that's the case, what does x really stand for? Like if you had to put it into words.
Goal scored. Penalty kick scored.
Is that what it is?
The number of attempts
Number of attempts until
he misses.
Is that, you with me? Okay. So if this is the case, do we have a set number of trials?
No.
No? My x is a number of trials, okay? All right, and what about my p? This is one of the ways they try and trick you. I'm telling you right now, which is why I always start with this, okay? By writing this out, because we've defined success. The question has defined success as he misses, not that he makes it. Do you guys see what I'm saying here? So what's my p? It is 0.16. And now we can do this question. So, wait a minute. No, we can't. I go to plug this in my calculator, and I don't know if I'm picking... What am I picking in my calculator? Geometric CDF. So, PDF. And y'all, if I'm gonna pick it, I'm gonna communicate it to Miss Meister so she knows what I did. Is it? This might be the one that was 0.08 that I was getting confused with.
Yeah, this is about 8%. It's like 7.96.
Okay. Do you guys see how the nuance of this a little bit? All right, now, let's look at part B of this. What is the probability that he scores on 5 or fewer of his next 10 penalty kicks? Okay, so are you guys with me that this becomes 5 or few is less than or equal to 5? And in this case, x equals? In words, what is this x, when we say x is less than or equal to 5, what is that x standing for? The number of goals.
So this is binomial.
And not just the number of goals, it's binomial. And now do we have an n? What about p?
0.84.
In this case, p is 0.84. I love these sets of questions. I think it really helps show some of the nuance of it. Bless you. Yeah.
How did you get point?
Because now the way we've defined success is he scores the goal on his penalty kicks, yeah? And this one is like 1.3% maybe? I'm doing that from memory.
0.013. Yeah.
0.013? Okay. Now, you guys remember that I said on one of the free response questions is going to include making a conclusion from a probability. This would be a great example in part C about how we might make a conclusion from a probability. Is everybody good? All right. Suppose that our soccer player's been out of action for several weeks. When he returns, he only scores 5 of his next 10 shots. You guys, is it likely that this guy can only score 5 of 10 shots?
No, not at all.
Not if he's still 84%, it's not, right? So if he only scores 5, that was pretty unlikely to happen by chance alone, right? Okay? So that's good evidence. So I might respond to this like, since an 84% shooter is unlikely to make only 5 shots. Or less. This is good evidence. He has become less that he has become less successful. And then I'm using PKs just to get a little bit more context in there. Okay? What if that probability had been like 15%? Then I might say, hey, it's reasonably likely that you could get 15% by chance. While it is a little bit of evidence, it's not a lot. Okay, it's not convincing to me. Cool?